afternoon, everybody. I think we've got a reasonable number here, so we'll make a start, and I'm sure more will join as we go on. My name is Mark Orr, and I'm the Executive Director of the UK and Ireland Spill Association, and we're putting together this webinar from the Plastic Pollution Working Group, and we've got we're now getting into the real meat of plastic pollution. And we're talking about today, we're going to be talking about identifying effective tools and equipment for microplastic recovery from shorelines and near-shore environments. So what I want to do is to introduce the association. We are the trade body for marine and inland response companies in the United Kingdom, representing contractors, manufacturers, it's nice to see some of them on here today, and consultants. And we also have an accreditation scheme through the International Accreditation Scheme, who deliver accreditation activities for inland responders, for oil and chemical spills, and we also deliver the Maritime and Coast Guard Agency scheme for the accreditation of marine spill response organisations. How did this form? Well, there were a number of plastic pollution incidents which occurred in 2019, and they just seemed to appear on people's beaches. There wasn't a real clear plan on how they would be cleared up. So the Environment Agency, in discussions with the Environment Agency, they asked if we would develop a nationwide response plan so that when plastic arrives on local authority beaches, that removal could be safely and promptly arranged. And that prompted the formation of our group. And as we started to meet initially, it became clear that it became obvious that this was clearly useful and it solved the problem, but then the mission became much larger. So we grew into a multidisciplinary group of companies, regulators, academia, and no doubt it will continue to grow. When the MV Express Pearl incident occurred off Sri Lanka in May 2021, it involved a number of the group's companies and a number of UK-based assets. And this is really the most recent incident where there has been a significant spill of nurdles with awful consequences for marine life, shoreline, local environment, and fisheries. And it has undoubtedly affected the economic health of Sri Lanka. Now, there's much learning coming from this, and there's been other recent incidents from which the group is learning, particularly MSC Zoe, which lost 345 containers in the North Sea in January 2019. And the contents of that spill impacted the Wadden Islands on the north coast of Holland and Germany. So these incidents are occurring, and our colleagues in CEDRA have also been dealing with intermittent releases, probably from a lost container or lost couple of containers containing plastic nurdles, which have flooded along the Brittany coastline. And whilst we're talking about plastic, I would like us to spare a few moments of thought for those dealing with the consequences of the loss of the Princess Empress, which was a tanker which has sunk near in the Philippines. And I know that colleagues from within our plastic pollution working group are out there helping the government deal with the consequences of that particular loss. The tragedy is that the vessel contains 800,000 litres of oil, and some of that is beginning to be released and is impacting beaches locally. So our thoughts for those as fellow responders, and hopefully the consequences of that loss can be safely dealt with. Now, turning back, with the live learning and experience building which is built through the MV Express Pearl, the Plastic Pollution Working Group decided we should share what we learn by collaborative production of a series of best practice guidance documents and webinars. And so far this year, we've conducted 4 webinars, or since this started, this is the 4th of the webinars within a series of what will become 8 webinars dealing with the different goals within this plan. So at the moment, the group is dealing only with microplastics, as they seem to be the area of greatest priority. And you can see the members which participate within the group's work. So the goals that we set ourselves The ones in italics are those that have been delivered. And today we're looking at goal 2, which is identifying the effective tools and equipment for microplastic recovery from shorelines and the nearshore environments. And what we'll do is we'll listen to the presentation, and we'll then have time for questions. And please, if you have a question, put it firstly into chat so that people can see the questions which are coming up. And please don't be shy. Do please feel free to ask questions. We want everyone to learn from everyone's collective experience. So I'd like to introduce Ria Shears and Tom Hunter from Oil Spill Response Limited, who are going to share their knowledge and their presentation with you. Thanks very much.
Good afternoon, everyone. So hopefully this will be smooth with us just sharing our screen with you. Mark, if you can let me know if that's come up all okay.
That looks just like it did when we practiced yesterday.
Perfect. Hello, everyone. So my name's Ria Shears. I'm a senior response specialist at Oil Spill Response. I was out in Sri Lanka for 9 weeks during the incident that we were part of the back of the Express Pearl incident. And my colleague, I will just quickly pass over for introduction.
Yeah, so my name's Tom Fisher. So I'm one of the senior response specialists at OSRL as well. I spent 6 weeks out in Sri Lanka working on the Express Pearl incident.
So what we're doing this afternoon, as Mark's already mentioned, we're going to talk to you about goal 2. So the identification of the most effective equipment for the recovery of microplastics from shoreline and near shore environments. So just as way of introduction for this particular goal, so the aim of this essentially was to get recommendations based on the experiences of all parties collaboratively within our plastics working group. So we've already mentioned Sri Lanka in 2021, but we've also got lessons learned from various different organisations in this team in Norway of 2020 and South Africa also in 2020. So 2 other plastic pellet spills that have occurred and organisations that we're working with have got their lessons from. So what we tried to do on this goal is to note what the research is that we have currently that are the best techniques for plastic pellet cleanup, but we also want to draw upon where we've still got gaps. So this is something that we are ever evolving in. So yes, we have a lot of lessons that we have at the moment and capabilities that we can utilise, but there's a long way to go. And I think that's fair to say for most of the goals, where this is quite a new aspect of cleanup in terms of plastics. So on the topics that we're going to cover for this webinar today, we're going to talk about the phases of a shoreline response, specifically to plastic pellets. We're going to talk about offshore and nearshore response techniques, as well as shoreline techniques. We will then touch upon a response matrix that we've put together, and this will draw upon the lessons learned from those 3 spills already, but also how potentially the adaptation of our oil spill techniques could potentially evolve into those different cleanup matrix as well, in terms of different shorelines that we haven't necessarily been able to test yet. We're also going to talk about important considerations that we should be thinking about when we're choosing the specific response techniques, and like I say, the future projects that we're looking to move into so that we can then start ongoing research and get some more lessons learned as we're moving through. So in terms of phases of a shoreline response, so we have 5 phases. Essentially, it may be that if you have a large scale impact, you may have various different shorelines in various different phases throughout the response. So it's, without going into each one individually first, I just want to reiterate that if you do have a large scale incident, you may have several in phase 1, but you also may have several in phase 4, for example. So you may have a variety of different escalations as you're going through, depending on the extent or the impact that those shorelines have been contaminated by those plastic pellets. So the phase 1 essentially is your initial stage. So as you can see in that photo, this is where you've got high volumes that are at high risk of remobilization. So this could be areas that are very environmentally sensitive, for example, that you want to try and stop that remobilization of those plastic pellets going to those areas. Some of the initial concerns in this phase as well could be potential toxic risks, especially if it's from a shipping incident. There may be mixtures of other chemicals that were contained within those cargo vessels, for example, that may be a concern. There also may be sources of additional contamination depending on the shoreline type that it's actually hit. So if you've got background waste or byproducts already on that shoreline, that mixture of those nurdles into that already contaminated area could also potentially pose a toxic risk. At this point, it's really relevant that we should then start to think about endpoints in terms of cleanup. So at what position are we actually going to finish cleanup on this shoreline? There is a goal that will touch on this in a bit more detail, so I don't want to go into too much on this. But within phase one, you should already be thinking about when you're going to finish your cleanup prior to you even starting it within this phase. Phase two is very much around bulk accumulation removal. So this is very much where we get in the nitty-gritty of the different techniques that we're going to touch upon today. This is still where you've got quite high areas of concentration of nurdles. You may also have background contamination starting to play a part of your challenges that you may have in that vicinity as well. And you also have this potential high risk of buried plastic nurdles. So if you're in an area of shoreline that has quite a lot of turbulence or agitation, currents, for example, that may help to bury those plastic pellets, that may also be quite a high risk in this phase. So as I mentioned, you could be using manual or mechanical techniques, which we'll go into a bit more detail later. Phase three is kind of halfway. So you're now looking at kind of medium concentration. So that's kind of the levels that you can see in that photo there. This is where potentially we're starting to see natural accumulation in certain areas. So it may be areas that predominantly will get quite a large buildup of background debris anyway, that wash up through the tidal cycles. So potentially this will only have the nurdle pollution or the plastic pellet pollution within the swash zones or the super tidal area. So you can see there as that tide has come in, those nurdles have then mobilized onto that shoreline along that swash zone. This is potentially where you've got kind of the longest phase within the shoreline response as well. So you've almost removed all that bulk accumulation, you've minimized that risk of remobilization, but actually getting this phase to the next phase may take months, if not a year or so, depending on what kind of shoreline you're actually dealing with. Again, various different techniques can play a part to aid you within the recovery of the nurdles within this phase. Phase four, so this is where you've got this low concentration. You may have quite sporadic or patchy areas of these plastic pellets. So it may be that only certain aspects of your shoreline is now covered within these pellets themselves. So this is where you start to think about cleaning that up to the end points that we talked about or touched upon just a minute ago, and actually thinking about, is this at a point where I can start to sign off this area because it's reached the point in which I can finish the cleanup. So again, this is where more kind of spot treatment methods come into play, things like vacuums, for example. These can be really used effectively to try and move forward to getting that agreed sign off of this shoreline. And then phase five, so this is something that even though the cleanup has finished, so there won't be those operations going on that shoreline, this is where we're going to look at implementing post-incident monitoring. So this is things like environmental sampling, making sure that we're still going out and doing regular surveys so that if there is a build-up in those natural accumulation areas, that they are then being spot treated again, and it's very much ongoing. This phase may take months again, or maybe up to years, depending on how far into the incident we are. For Sri Lanka, for example, some shorelines are within this phase, but where there is still cleanup within those other phases, this is going to be ongoing for quite a considerable amount of time. Okay, and with that, I will pass over to Tom, and he's going to talk about the initial aspects of offshore and nearshore response techniques.
Thank you very much. So the first technique that we're going to have a little look at is containment recovery. So this is attempting to capture and remove plastic pellets from the environment, either offshore or near shore, only if viable though. So There may be issues in this in terms of safety or window of opportunity that will allow this to happen. With an instantaneous spill, there might not be time to get to the site, deploy the equipment, and then recover. However, if it's a continuous release, an ongoing release into the environment, this could be an option that we need to think about. The use of this is using containment booms to collect any free-floating plastic pellets, and then using either like nets or sieves or something of a similar nature to then recover it from the surface once it's collected. There are various pieces of equipment that are available and that we use for oil spill responses that could be repurposed for this, but there does need to be a little bit more research into their use and the effectiveness of using those bits of kit to recover plastics. The goal of this is to prevent or reduce the impact of those plastic pellets on the shoreline. That makes it easier because they're less likely to be contaminated with other debris, and also they're less likely to be buried or stuck in that sediment, and therefore reduces the requirement long term for preparation and also waste management, which we'll talk about a little bit later. We do also need those trained personnel. So if we are using this equipment, then we need people who know how to use it, but also to have the equipment there and available to use in country, especially if it's at those first few days of a spill. So the next one we're looking at is protection. So this is the idea, and it's a priority really, to reduce the risk of microplastics entering highly sensitive areas. These could be your salt marshes or mangroves. So when we talk about oil spills, we talk about the environmental sensitivity index. This is identifying environments that might be particularly sensitive to oil spills, but it can also be translated into spills of plastic pellets. And it gives us an indication of where we might need to protect. Depending on the incident, again, similar to containment recovery, that window of opportunity that allows us to get in quick enough to put in this protection booming may not be there. Again, if it's a continuous release, it could be something that we can consider. It does also, again, require trained personnel to use the equipment to be available, and people that are competent to use it, as I say. Next slide. So the next ones that we're going to start looking at is if we are unable to stop the plastic pellets contaminating the shoreline, we'll start looking at response techniques that we can use there. So the first one that we're going to look at is sieving. This is probably the primary collection method for spilled plastic pellets. It's use of sheet sieves to separate the plastic pellets and the substrate or other debris, with the intention that sand and other small particles will fall through the mesh, and the plastic pellets will remain on top. The size of the mesh can then be adjusted to suit the size of the material that's being recovered. Generally, this is pretty useful. There is availability of equipment or the availability of manufacturers in order to produce the equipment, such as the sieves, which are fairly basic bits of kit. We use this for moderate to lighter levels of contamination, and generally only on dry sand. If we start trying to use it on wet sand, then the sieves start to become clogged and become ineffective. We need to think about, in terms of the manpower that's going to be required for this. It's fairly labor intensive. As you can see from those images, it needs 2 people to operate the sieves, and then an additional person to be shoveling the material into those sieves for it to be processed. What we do also have is more than just the plastic pellets remaining. So if we've got any material that's larger than the mesh size, then that's going to remain on the top and therefore requires further processing. So one of the techniques that we can use for this processing is flotation. So this is the use of a container half filled with water, and once it's been processed through the sieves, or if there's material with high concentration of plastic pellets, we put them into these containers. The plastic pellets will float, and any sand or shells or more dense material will sink down to the bottom. and we will then use nets, or as you can see in this image, plastic sieves to recover the nodes from the top of the water. It can be used, as I say, as a technique on its own if there's a high concentration of plastic pellets within the material. It's fairly effective in terms of the equipment is readily available in country, but again, it does require a large number of personnel, as you can see in the images, to process the sand and the plastic pellets in this way. So a couple more techniques that we can look at is flushing. So this is the use where volume and pressure of water is applied in the attempt to remobilize the plastic pellets from the substrate. The mobilized pellets can then be recovered either within a boom or using other strategies to recover them further towards the shoreline. The pressure as well as the volume needs to be considered when it's applied based on the shoreline which we are looking at and working on. Depending on the type, so for marshes and mangroves, we might use low pressure but high volume just to get that to flush out. And then your exposed shores and riprap, we can look at using higher pressure, but again, higher volume. There's many ways of doing this. So again, this is something that we use for oil spills, and it's repurposed potentially for plastic pellet spills. So it's using perforated hoses, as per the image on the left, with pumps to push through water, and then a boom in a horseshoe shape to collect those plastic pellets and cover them from the surface. Another technique that we've both used and is very effective is trommels. So these are often used for separation of industrial waste and within the construction industry. And the idea is you feed the material into one end, and the material is sorted by size with a smaller mesh at one end and a larger mesh at the other. So as you can see in the video that's playing now, that material is turned around and spun around, and it starts to begin to sort itself as it travels from one end of the trommel to the other. This is really effective for separating sand and plastic pellets from large debris, and then the pellets from any finer sand. Again, there's an important message of checking the mesh size. So depending on what we're trying to recover, the mesh size can be adjusted to recover larger or smaller materials. They can be fairly big, which is a consideration. If we can't get them down to the size, then we might have to resort to again the sieves rather than trommels. But it does reduce the amount of manpower and also the physical requirement of sieving. So over to you, the next few.
Cool. So the next one that we're going to talk about is vacuum. Pretty much what it says on the tin, essentially. We can either use local resources such as leaf blowers that can be adapted, or we can use other vacuum kind of based equipment for this technique. It's really good to be used in vegetation or riprap areas. So areas that potentially don't have that background debris is really good as well, because of that separation not being applicable for this type of method. However, there is some degree of training that is required, with this being more of a machinery type of equipment. So that training will need to be considered, and some basic health and safety of how to utilize this equipment safely is needed as well before use. Again, in terms of mesh size, this is something that again can be adapted based on the size of those plastic pellets that we're dealing with, as well as any of that background debris that may cause a bit of an issue with the utilization of this method. Another one that comes with this particular method, along with the rest of the techniques, is also the consideration of welfare of the personnel that are using it. So these types of equipment can be quite heavy, especially if you're having to angle that nozzle at a certain degree for the effectiveness of this technique. So making sure that you're looking after the welfare of the personnel that are actually using the equipment at all times is something that needs to be considered throughout this technique. In terms of selectiveness, as I said, sometimes the mesh size can help with this. However, you want to try and use it in areas that there are less of that background debris that could be collected or potentially clog those nozzles on the equipment. Another consideration, especially if we've got sensitive environments surrounding the area that we're cleaning up, is from a wildlife perspective. So these can obviously produce noise pollution. So understanding what the different sensitivities are around that area, whether you've got breeding grounds potentially for any bird species or any other types of wildlife within that area, is something to consider as well in terms of whether this is a technique to use as part of your strategy. We can also then transmit the sieving techniques and the trommel into more of a mechanical means as well. So this aids in terms of that background debris separation, but it also minimises that labour need. So a lot more labour, a lot less labour is needed, so less intensive. You can also use these types of equipment in field if you've got that already set up, or you can use it in the main waste storage area. So if the material has already been collected within the first phase or the second phase, for example, this can aid in that secondary separation of that waste management if it's required as part of that waste plan. In terms of logistics, again, as you can see on the right-hand picture, these can be quite big pieces of kit. So in terms of actually finding something like this in country, you may need something like a blueprint, for example, trying to find someone that can manufacture this in country, but also the logistics of actually getting it to the area where you might have that waste storage area for where it's going to be set up. And also the security around making sure that it stays where it needs to be. Again, in terms of mesh size, this is something that needs to be considered. So very much a common theme with the techniques that we've talked about so far. And yeah, you may need to actually get this either made in country or potentially shipped in or flown in, depending on where you're getting this as part of your strategy building. The other thing that you can do, so these are techniques that you may use for kind of your final polishing for beach combing. So this is something that's good for phase 4, for example, when you're doing your spot treatments. It aids, again, that background separations, but however, you have to use it in quite distinct shoreline types. So it can't be used on wet sand, and it's no good with any kind of inclination on that shoreline. So it was something that was brought in as a technique that was thought to be something that would aid in the response completely. However, these were quite limited in the areas that they were actually effective on. Again, it still resorts to reducing the amount of labour that's needed, and these can cover a larger area. But it's also worth considering, again, where you're going to use them, the logistics of getting them to the site, the security of where you're actually going to house these equipments, and they may not be locally available as well. So in terms of that global footprint of your response, these may be something that you need to purchase out of country and actually transport them in and get them cleared through a customs or something like that in country. The other form that you've got is mechanical excavation. So with this one, this is predominantly used within phase 2 to 4, depending on the type of machinery. So you can see in the left-hand photo there, you can use an excavator. So this is kind of the utilisation of those local resources that may be of benefit. However, you again need to think about how you're going to remove that sand. So as you can see there, making sure that you're very selective on the amount of waste that you're generating through removing only the top layer of that substrate, for example. They're really good for covering a large area, and they can assist with a large scale berry nurdle removal as well. So if you've got nurdles in quite a large depth across a large area, sometimes this is a technique that's beneficial for the cleanup in those respects. They can potentially generate a large amount of waste, as I said already. So if you've got constraints in the amount of waste storage that you have, it's good again to make sure that you're selectively picking up the nurdles themselves or the plastic pellets themselves and a very limited amount of substrates. And you also need to make sure that they are being used correctly by the people that are operating this machinery. So making sure that they are trained to be able to use these machinery correctly. Also going through again this health and safety aspect with the guys or girls that are utilising this machinery. Again, this may be something that is used for a larger scale. So it may be that you need to start to consider this alongside another technique, for example, as you may need further separation. So building in sieving or the use of a trommel, for example, alongside this type of technique could be something that you bring in as a strategy so that you've got an additional separation process for what's being removed off of the surface. So this is a bit of a summary in terms of the response techniques that we've already talked about with you today. So what we've tried to do is categorize the different techniques alongside the types of shoreline that they may be most useful on. As I mentioned already at the start, this is something that we've drawn upon as a collective with all the organisations as part of the group. For either things that we've learned through the different spills that we've already tried to respond to, but also those that we can potentially adapt from oil spill techniques as well. So as Tom mentioned, containment recovery being one that we still are yet to test, but based on how kind of plastic pellets behave, we think it's still prevalent that this would be a good technique to use. There are some considerations again that we need to think about. We touched upon the environmental sensitivity index, but also net environmental benefit analysis. So this is the idea of choosing essentially the best recovery technique based on the environmental and socioeconomic values of that shoreline type. So thinking about, is it going to create more harm than good, for example, in terms of applying that technique to that shoreline type. So for the likes of marshes and mangroves, there's always a consideration as to which techniques we need to think about in terms of, do we actually go down the protection route rather than allowing those areas to be impacted first and foremost, and then considering if we have that impact, how we're then going to deal with it most appropriately. But it goes without saying, those two principles are definitely something that we need to consider across all shoreline types, so that we can make sure we're choosing the right techniques as part of building up our shoreline strategy.
So, as we mentioned throughout the kind of presentation, there's a number of considerations that we need to use when we're using these techniques. The first one, and most importantly, is safety. As always, with anything that we're doing out in the field, safety of our personnel, or response personnel, contractors, or anybody that's within the vicinity of operations, quite important. Identify the risks and mitigating them. So waste management being aligned with common good practice. There's many documents, there's a lot of kind of research on waste management, and making sure that we're doing it in a way that's responsible and recognised. And then along with that is, it comes up later. So we'll look at welfare first. So again, this sits in safety. We just need to, this can be as simple as provision of toilets or water and food, but also shade, and depending on PPE requirements, ensuring that the breaks are taken and that we're looking after the people that are there to help. And again, with that is the training. We need to make sure if we're requiring these people to use equipment and to go out into the fields, that they're trained and they're supervised, to make sure that they're doing it appropriately, but also to make sure they're doing it safely. So this is what I was trying to refer to earlier. So the selective removal contamination. So this is about just trying to recover the thing that you're trying to recover. So where we're talking about plastic pellets, ensuring that the majority of the stuff that we're taking away is plastic pellets and not organic debris or anything like that, that will increase the amount of waste that is having to be processed, but also that material remaining on the beach could be important for the ecosystem that's there. And also the global footprint. So we need to have a consideration that this needs to be proportional in relation to the size of the plastic spill. If it's only a small number, then it can probably be dealt with locally. Whereas if it's a significant spill, there might be more of a requirement to bring people in internationally who have the experience and skills to deal with this. So the last thing that we need to kind of talk about is future projects. So with the plastic pollution working group and the collaboration between the different organisations that are part of it, there's going to be this ongoing development. So the testing and developing of equipment, in preparation for any kind of future incidents that take place. And the sharing of lessons learned. So by having this collective of knowledge and experience, and anything that should happen in the future, these spills of opportunity, we can use that information to continue to develop these techniques and strategies to respond to any plastic.
So with that, we just want to draw the webinar to a close and ask if there's any questions, but also direct you to the next webinar in the series as well, which is on the 19th of April, same time, same place, goal for looking at qualitative and quantitative assessment of microplastics in sediments and water. So ourselves and CFAS and UK Spill will be leading on that presentation and that webinar for that one as well. But with that, I will just take a pause and we'll see if there's any questions.
Yeah, can you hand your screen back to me, because I've got a couple of points I want to make as well, if you could. Thanks, Ria. Thanks, Tom.
Okay.
Thank you. Right. Great. Okay, so a couple of things I want to make is, don't forget the size of the problem that we're dealing with. And I'm sure that many of you would have seen that in the press lately, there's a lot of talk going on about just the scale of the problem that's out there at the moment. Now, all of these plastic bottles and plastic, everything has to be manufactured, and it's all coming from nurdles. And there is at the moment, 19 to 23 megatons of plastic entering the aquatic ecosystem annually from land-based sources. And there is a lot of talk about what's going on with the amount of plastic going in, but there aren't massive steps being taken to stem the flow of plastic going into the sea. And I know that IMO are considering it at their April meeting, and there's quite a lot of lobbying to try to get microplastics or plastic pellets, plastic nurdles, plastic flakes, actually categorized as some form of hazardous waste, or having a higher priority in the waste hierarchy, so that the packaging of the goods as they go into containers can be better. And we would welcome that we'd certainly welcome that within the group, and we're talking to members regarding that. But it is really, really important. A couple of things I would like to make is weather does have a significant effect on how the microplastics move from one part of the response area to another. And it may be that you've signed off an area that is being cleaned, but actually you have a storm and it regurgitates those which are on the seabed. So your work has to be completely reviewed. And in phase 5, there is the part about ongoing monitoring. That is really, really important. I would also say that, comment that there's actually been quite a lot of work which is being done in Norway, and they through Sintef, but also through other research operations in Norway. Quite a lot of work has been done, and they've got some really good stuff which can be looked at. One consideration within these spills, particularly when you're managing staff, is you've got to be aware of what the nurdles have been contaminated with. Because if you have a mix of products, as in the Express Pearl, which has been lost from the froth from the vessel, some of them will be affected by fire. And what effect has that had on the nurdles within the what coatings have the nurdles got on them, and how is the impact with heats or acids or other products done to affect that? One thing that was found on the Express Pearl is that some nurdles clustered together because of fire. Some actually were affected, scorched, but actually it made them quite dusty to handle, and you don't want to be breathing that stuff in. And there is a point that when we go back to goal 5, environmental and health risk associated with microplastics, you do have to reassess the respiratory protective equipment and the personal protective equipment that operators are wearing as you work on different parts of the affected area. One thing to say is that later this year, we'll be working with Cedra over in Brest to do a series of trials on equipment that is used to recover, but also equipment that is used to segregate the equipment. And we're going to share our knowledge with Cedra and with others who are going to be involved with the trial, that we can update this webinar with our findings from this. The other question I'd like to pose first to Ria and Tom is, when you are recovering the pellets, it's quite a labor-intensive operation. And how did you manage that? Because there must have been a lot of people involved. And was it something that you expected?
So I think there was differences with this kind of spill compared to the normal one, in the fact that we also had COVID-19 at the time. So in terms of personnel that we could get to support the cleanup, there was very limited kind of volunteers that were able to be brought in terms of the spill, or responders themselves. So it was very much drawing upon personnel from military background. So we had 3 different types of military background agencies working alongside us as part of the cleanup. So as you can imagine, having that diverse range of organisations, you get different kind of hierarchical needs, I guess. So passing the message through the different chains of command was something that was quite a challenge, I think is fair to say. Also in Sri Lanka, we had the different organisations had different regional backgrounds to which they spoke various different languages. So even kind of the army versus what else do we have? Kind of the marine organisation that was there, they spoke different languages themselves. So when you were putting teams together, you had to obviously be aware of that language barrier that could be setting as well. If you've got anything else.
Yeah, the benefit was as the spill kind of continued over time and COVID became less of a concern, we were managing to engage much more with the local communities, which was really beneficial for us and them. There was this engagement piece of getting them to come in and provide manpower. There was to an extent, a financial benefit to those that were assisting us. There was the benefit to us was that the plastic pellets were being recovered quicker. They knew the local area, they knew where those kind of natural accumulations were, so where to go and target, and they had a vested interest. But also, they were used to the climate they were working in, rather than quite hasty person like myself going in, not being used to the sun, not being used to the heat. They were used to it and able to provide that labour and manpower.
So that's a good point. Just in terms of questions, we're going to take questions, but there's a couple of questions that are in the chat. One from Min Yang, who gave a very good presentation last year at Interspill. Her question was, thanks for the interesting presentation. Regarding the boom used for offshore nodal removal, have you considered its efficiency? I'm concerned that the nodal particles may easily migrate across the boom from the subsurface. Ria, Tom, anything you want to comment on that?
Go on.
So I think this is fair to say that this is something that we haven't trialed as of yet. So something that we are looking to do as part of the trials next week, I believe. Actually, whether these booms could hold the nurdles as we think they will, or the plastic pellets. So it is a worry or a concern that we do have, that they won't hold them correctly. However, what we are hoping for is that it will behave the same way as which oil does in terms of that containment. That will then allow us to be able to recover those plastic pellets that are within that apex of the boom, so that they are then reduced from going out offshore further, or remobilizing another area. I can see Connor is there as well. We did look through the list, Connor, and I think you're under a different name, which is why I didn't know if you were on.
Yeah,
I think I clicked on someone else's presenter link, and I don't know who Mel Fitzsimmons is, but that's not my name.
Connor, I don't know how you got that. I don't know how you got that link. But anyway, never mind. Nice to see you, Connor. Connor, you're from ITOP. And so you've been quite heavily involved, or your colleagues have been heavily involved in producing the report and in helping with this presentation, but they were deployed to Philippines. So that's why they're not here. So yeah,
Yeah,
Connor,
indeed,
I mean, are there points you want to make which we perhaps have skated over that you would like to place with your experience from, or ITOF's experience from Sri Lanka? Are there points that you would like to stress in the difficulties that had to be overcome in recovering plastic?
Yeah, so I mean, well, there's quite a lot of things to say really, but I came on camera just to mention about the personnel.
Yeah.
Just to sort of give an update for those listening of the situation currently. I just got back from Sri Lanka just over a month ago. I was there in total for about 6 months over the last 2 years. And currently there's still about 150 people every day employed currently by the Marine Environmental Protection Agency there. So how it worked from the start was there was over 500 people from the forces, like we mentioned, the Navy, the Air Force, and the Army, and then slowly over time that was taken over by being managed by MIPA, the Environment Protection Agency in the country, and they employed, as Tom mentioned as well, local workers who were affected by the fishing ban in the area as well. So that was quite nice. I just wanted to sort of put some numbers on those things. I think we had a lot of problem in Sri Lanka with normally an organization would come in and provide the workforce, but in this case the government chose to do it themselves. So there's been some differences from other cases in that respect as well.
Certainly the experience of some of the UK spill members dealing with spills in the UK. During COVID, everyone got to love their local beach. And when we've had spills and we've had to recover them from beaches in the UK, one of the, I would say, challenges is making sure that some of the volunteers acted safely and actually fell under the local authorities' control, not the responders' control, because they are, and it can become an issue because enthusiasm can overcome that objectivity about safety. And any comments that either yourselves or ITOF want to make on that?
I think it's fair to say that we had differences within our safety. I mean, in terms of OSRL, and I'm sure ITOF as well, from the backgrounds that we're normally working in terms of oil and everything else, in terms of response, the level of safety is at the highest level that it can be.
Yeah.
When it came to this response, I think there were some differences that were shown in terms of kind of the personnel that were working in those areas. So kind of heightening the need for mandatory PPE in certain respects. So the use of gloves, making sure that shoes were worn at all times was a conversation that was repeated several times. I can see Connor not. So yeah, things like that in terms of those differences and making sure that we were bringing those personnel up to the correct safety level that was recognised for that specific scenario. In terms of it not being an oil spill, we didn't need to be as stringent with the level of PPE, for example. So that was something that we looked into with ITOF of actually what is the level that we need for this particular spill. So from a welfare perspective, but also from a health perspective, it's at the right level. But yeah, there was a few discrepancies there as well. And I mean, Connor or Tom, if you want to fill in anything else with that one.
I've nothing more to add, but Connor.
Yeah, you're putting it very diplomatically. Yeah, no, it's a different standard there. There was a big battle to get people, as you say, to wear shoes. I've seen people operating a crane and lifting containers, standing under the container, never mind wearing no shoes at all. One of the risks I wanted to highlight in this case was the issue of containers washing ashore. And obviously there's the threat of HMS in this case. So in that aspect, the role of the in particular the Navy was quite key actually in making sure that the first thing local people do, particularly in Southeast Asia and a country like Sri Lanka, is they go and they try and open that container to see what's inside. So the role of the military forces was quite key there. Because obviously that was a big concern, and there was a need for quite rigorous PPE for when the containers were eventually opened and removed. So that was a big aspect of the case as well.
A question from Josh to Ria and Tom. On that future project slide, you had the drawing. What was the prototype equipment design that you showed?
So there was two types on there. So one was around the beach sweepies themselves. So
Yeah.
kind of utilizing the idea of a beach sweepie, but making it more of like a mechanical sieving type push along shaker plate. Yeah, that's the word. Thank you, Tom. So they were both two designs that we came up with the local manufacturer.
Yeah.
And the one on the left was more of a design around a mechanical trommel. So this was to aid some of the secondary waste separation that we wanted to try and implement in the storage area, the main storage area. So yeah, both of those were blueprints that we drew upon, and we've got access to off the back of the work that we did with the local community.
Yeah. At the moment, Josh with Ria and Tom, I think, are working with Southampton University on a group design project. Do you want to say anything on that, either Josh or Ria?
Yeah, so next week we're trying out their prototype as part of our first trial that we're doing. I won't take any limelight. I mean, Josh is on the call, so I mean, the more the merrier with this. If Josh, you want to explain a bit the forefront of that project that we've been working on.
No, Josh is shy.
I'm looking at it, and the noise might be a bit weird, but yeah, not really too much more to say there, really. Yeah, we're looking forward to trial. Thanks to Ria sorting out. So basically going to trial several different things, and especially the containment idea, looking at flushing as well potentially. So yeah, it should be really good. That sort of we've got 6 students on a 9-month-long project, and they've produced so much really interesting data so far. So yeah, looking forward to it.
From your trials next week, will you get any video?
Yeah, I'm sure we can do.
It would be good, because actually it's an opportunity to put together a series of videos showing the collection equipment that you're using, because I think it will illustrate to many who are not actively involved as responders just the implications of using different types of equipment, both from a manual handling point of view, plus also a sort of employee how to put it, some of the stuff gets quite hard to use after a long period of time, because some of it's quite heavy, it requires quite a lot of concentration, and you just have to rotate people through the roles that they're doing to ensure that they are efficient when they're doing it. So that's good. So the group design project, that's going on. Mark Dix has just popped a note through. Given the possibility of remobilization of material, what should be considered when determining cleanup endpoints? That is, how clean is clean. Is this a visual determination? Are there better numerical means, e.g. so many pellets per square meter, etc.? We touched on this in the presentation, which was under Goal 5, environmental and health risks associated with microplastic, because we did discuss within that the endpoint determination. And some of the things that we covered were, and this is sometimes quite hard to find, is what was the baseline before you went there? And some would say that the determination being used is basically want to get the beach back to the condition before this incident occurred. Now, if you're perhaps around the UK or in European waters, you probably have a good indication of that. But I think one of the stresses, or one of the issues with Sri Lanka, is there was no real baseline assessment, and culturally they have a different attitude to environment, the pollution on the beach, to that which we might have in Europe. In other words, the beaches tend to be dirtier. So any comments that Connor or Ria want to make on that?
Probably one for Connor, and I'm going to pass it to you, Connor, because you're probably on.
I thought you might, Ria. I thought you might.
We touched upon it when we were out in Sri Lanka, but actually we weren't there for kind of the foreseeable of actually seeing this implemented. So I'm not aware of what the solution was with those. So Connor, you're probably best placed for that question, if that's okay.
Yeah. It's quite a difficult question to answer, actually. And we have been looking at lots of different, trying to develop a method to determine when to stop the cleaning. Because as Mark mentions, there is a lot of background plastic in Sri Lanka. People literally tip their kitchen bins into the sea behind their house. So in this particular area we're working in. So you have to think about that as well. And the method we've determined, we've been investigating is using a quadrat. So laying that on the beach and counting what percentage of that quadrat has nurdles present in it and what percentage has background plastic in it. And then we've got a matrix where we decide, it's not a finalized method, but that's what we were trialing. And as you mentioned in your question as well, the remobilization of material is a massive problem. There are beaches where I couldn't find a single nurdle on them, but then the next day after a big blow, the beach is covered in plastic again. So this has happened repeatedly, constantly over the last 2 years. So it's quite a challenging thing to sort of sign off the beach. I think it's a problem that's specific to Sri Lanka, though. The particular sedimentology of Sri Lanka, the coast there is very mobile, and it wouldn't be like that everywhere else. And I certainly wouldn't expect it to be like that, for example, around the area where the trans-carrier happened in Norway. But of course,
but it was an issue on the Rainer, wasn't it? Partly because of the local currents which ran up, which when they had a big storm tended to flush product which was buried deeper at sea, in the deeper sea, and then was flushing it ashore. And I know that diminished over time, but I think when planning an endpoint, you have to be considerate to the fact that there is product going to reappear, maybe not forever, but there's going to be a need for ongoing monitoring and possibly recollection.
I think there's more research that needs to be done in terms of how we do an endpoint for an oil spill, then a certain percentage of oil still remaining that we then leave to naturally degrade, because that's more environmentally beneficial, because you're not going to sterilize the environment or over clean that environment. With plastic, that could be slightly different, because it does degrade in the same way that oil does, where that endpoint might be very different from how we consider on an oil spill. So I think there's more research in that needs to be done as well, so that we can make clearer judgments on these endpoints for plastic.
Yeah, I think hopefully, Mark, that answers the query in that there isn't really yet a fixed answer, and there's no fixed. I mean, we're learning by experience, and I would say that the experiences are not just unique to us. This experience is we collaborated together to produce knowledge, which hopefully we're sharing with lots of other people, and we really would invite people to share information with us, because I think we're all learning as we go with this, and the more quickly we all share the knowledge that we've got, the better can be the way that responses to these are managed should they occur, and the way that responders will be better prepared with equipment, training, and will have knowledge of techniques that others have used when they're faced with the problem arriving on their beach. And if the group achieves nothing more than making people aware that it is an issue, but there is a body of knowledge which is available through our website to access that, then so much the better. One thing that the group is going to collaborating on is we are going to be producing later this year a field practice guide, which will be a summary of the knowledge that we've gained. But again, it will be a dynamic document. It will be available through our website, and it will be and obviously it will be spread about that it exists through our partners like ISCO and to other bodies, including the members of the group. So it will be easily accessible, and it will be updated as experience builds. So I think, go on. Yeah, go for it.
Sorry, Mark, to interrupt you.
That's all right.
I wanted to make this point earlier as well, and I might be putting my foot in it a little bit, to be honest. I I just in presentations we give as well, and the one that you just gave, Ria and Tom, I think that there's quite a big focus on the mechanical machinery, and I'm talking specifically about the Express Pearl here. There's quite a big emphasis on the mechanical aspect of things. But in practice, what we found on site, and bearing in mind, you know, it's almost 2 years, something like 21 months since the incident happened, none of that mechanical machinery was actually used any more than a week, honestly. The sweepies, for example, we found that there's not very many sites at all where they're actually appropriate to be used for lots of the negative points that were highlighted in the presentation. But a lot of sweepies were taken to Sri Lanka, a lot of trailers and trail behind tractors were taken to Sri Lanka, shaking tables, water separation systems, trommels. But at the end of the day, what really was effective on the beach was 2 people with a sieve. Lots and lots and lots of people with sieves. And you know, that can be backed up quite rigorously with the data from the amount of nurdles collected. And I think that problem comes from the fact that over time the nurdles become dispersed, so they're not concentrated anymore. Also, the beaches in Sri Lanka are not uniform flat surfaces. And even, by the way, on a uniform flat surface, the beach species don't really work that effectively for nurdles. And also, there are beaches where there are tons and tons of logs washed up, and domestic waste of all kinds. And when you've got that in the mix, these kind of machines basically just are completely ineffective, and don't work at all. And the conclusion from that case, in my own view, is that these machines are not effective for this type of response.
I think it's worth saying that the same way as we pick our techniques for building an oil spill strategy, everything's on the table based on the scenario, and then you eliminate all the positives, the negatives, as you said, Connor, depending on that scenario, which ones fit best in terms of that effective recovery. So yeah, for me, everything's on the table until it's not, I think is fair to say, and the reasons, whether they're positives or negatives, will then establish which ones are the right techniques based on that scenario.
Yeah, I don't mean to be very negative or anything.
No, I'm with you. I was a sieve and a flotation device in Sri Lanka. I'm with you.
Yeah. I just have to present the reality. You know, we had 600 metal trommels made for this incident, and all of them now are sitting unused in a warehouse, and you cannot. Nobody wants to use them because they're ineffective, basically. Sadly.
Quick question.
Yes.
Quick question to Ria and Tom and you, Connor. You mentioned that wet sand provided a specific problem when recovering with certain equipment, presumably the trommels. Which gave you the best results? What technique gave you the best results where wet sand was involved?
So we saw that question come up, and we were sending the message back to Pete, and for us, I think collectively was the use of those flotation devices. So when you've got that,
okay,
in terms of the sieving and everything else, it just causes that clump of that mesh, so it doesn't allow that separation process to work efficiently. So using the buoyancy of those nurdles against the sediment that we're trying to remove from that flotation really worked well for our personal.
Yeah,
I would tend to agree with that actually, but I would say that the flotation should not be the primary means of separation.
No.
It should be like a final, after the sieving has been completed, to wash that last bit of sand off. It works very well.
it's again that trial and error approach. So having all those techniques available, giving them a go and seeing which one works best. So sometimes it's the simplest, the sieve and a bucket of water. Sometimes the trommels were effective, sometimes they weren't. It's trial and error to see what works, where it works.
And it's difficult, right? Because I'm sure there's a scenario out there where an enormous beach grading machine would be the ideal solution. But just in this specific case, it didn't prove the case.
And I think that's the take.
So like most instances, just having a toolbox of techniques up your sleeve and the equipment to match it and tailor it to the incident that you're dealing with at the time.
Yeah.
Good. Well, time's running on, so I'd like to thank Ria and Tom from Oil Spill Response and from Connor for chipping in from ITOC. Really appreciate your time and your effort and your contributions. thank you all to those who've attended. This webinar is being recorded, and no doubt within the next 48 hours, I'll get the edit, or I've done the edit, and we'll be sticking it up on our website. You can see this, this webinar, plus the report which goes with it, which is a more detailed, if you like, summary of some of the analysis of the equipment and importantly, the matrix. That will be contained together, and that will be up on our website under the Plastic Pollution Working Group. And I'd like to thank everyone for presenting questions, which have been excellent. And thank you very much indeed for attending. You'll be able to see us all again on the 16th of April. And yes, it will be in fact almost probably the same team presenting. So thanks very much for that, and see you on the 16th of April. Thanks very much indeed. Bye.